from across the globe, from the centre of aerospace. And now to you.
Thank you for downloading the Aero Society podcast from the Royal Aeronautical Society.
Okay, good evening, ladies and gentlemen, and thanks for turning up. There's quite a few of you, which is good. I think half of Martin Baker are here. So thanks for the support. What I'm going to do initially, I'm going to play a corporate video, the company video. It'll give you an insight as to what we actually do at Martin Baker. And then I'm going to make a little apology. We're going to have a little bit of death by PowerPoint. Hopefully you'll find it interesting, and hopefully at the end we'll have time to go through some questions.
Martin Baker has for 60 years been perfecting and constantly improving their ejection seats and life-saving products. During that time, they've produced over 70,000 seats, equipped 93 air forces, and saved more than 7,200 aircrew lives. This relentless pursuit of perfection has placed them on the cutting edge of safety. Modern combat aircraft demand a highly complex and sophisticated ejection seat that's fully integrated with the aircraft cockpit and systems, seamlessly connecting the pilot in the cockpit with the life support and weapon systems alike. Using the latest design techniques, every feature of the system is analyzed, computer simulated, and even molded in thermoplastic resin to produce a 3D working example. From the outset, the escape system, including interseat sequencing and ejection path clearance, will be fully analyzed by computers in the hands of experts. Before the first metal is cut, a team of designers and engineers will have used the very best techniques to confirm that the design is good and that it will perform as required. Ultimately, the seat must be tested for real. But by then, the design will have matured so that work can progress with confidence and with a minimum of risk. A factor that's vital if an aircraft program is to remain on cost and schedule. Safe in the knowledge that the components perform as advertised, testing of the subsystems, the building blocks of the escape system, can proceed with confidence. With the subsystems working, they can be brought together into a life-saving escape system. A fully representative forward fuselage, complete with escape system and instrumented test dummy dressed in the appropriate flight clothing, is married onto the special Martin Baker designed and constructed track. Telemetry and photographic coverage equipment is prepared to record exactly what happens. A pusher sled with its bank of rockets is then coupled behind the fuselage and the final adjustments are made. Ejection, stabilization, deceleration and parachute deployment take only 2 seconds and at low speed require less than half that time. Tests such as this will check the operation of the ejection seat itself so that testing from the aircraft itself can begin. Only in this way can the complete end-to-end testing of the entire system and its interface with the aircraft demonstrate conclusively that the system's ready for flight. The Mark 16 series of ejection seats represents the very pinnacle of 60 years of aircrew safety achievement and is available in versions which meet customer needs and aircraft performance. For this reason, it's been selected for all the latest aircraft programs, including KT-1, Texan 2, PC-21, LCA, Macchi 346, Golden Eagle, Rafale, Typhoon, and F-35 Joint Strike Fighter Lightning II. It's also been selected to upgrade the escape systems in aircraft such as the Northrop F-5 and the T-38 Talons of both NASA and the US Air Force. An escape system must work perfectly the first time. Only Martin Baker has the depth of knowledge, capabilities, and unparalleled experience to ensure that aircrew safety technology remains on the cutting edge.
Okay, hopefully you didn't find that too boring. One thing I will point out, you've all seen the video there, you'll have noticed maybe some of the ejection seats coming down on a parachute, some of them attached to the mannequin. That doesn't happen on a live ejection. That's purely so that we can get the seat back, because we need to be able to analyze the seat and make sure that everything is operated normally. So normally the seat will not have a parachute, it will just fall to the floor. And a lot of people have said to me, well, what happens if it hits somebody? Well, it's simple. It'll kill them. People forget about the 20-ton of aeroplane that's also falling out of the sky. So, what I'm hoping to do tonight is go through the history and development of Martin Baker, but you'll notice I've highlighted with the yellow, between Martin Baker, Martin-Baker. Well, I'm sure a lot of you are aware, Martin Baker started life as Martin's Airworks back in 1929, and we manufactured 4 aircraft. As you can see, MB1, MB2, MB3, and MB5. It's not because we can't count. MB4 was actually on the drawing board, it was being built, but MB5 superseded it. Now, I don't know if the people at the back of the room can actually see that, but MB5 over on the far side there had contra-rotating propellers. By all accounts, it was a fantastic aeroplane, but unfortunately it came towards the latter end of the war and there was no call for it. So, the Martin Baker, where did that come from? Well, the Baker bit comes from Sir James Martin, who started Martin's Airworks, but he hyphenated the name, changed the name to Martin Baker, in memory of his good friend and confidant, Captain Valentine Baker. Unfortunately, Valentine Baker was killed test flying MB3, where the engine of his aircraft seized, and he put the aircraft back down, but unfortunately, unbeknown to him, the aircraft struck a tree that had been cut level with a hedge, the aircraft flipped, burst into flames, and unfortunately, Valentine Baker was killed. So, why do we need escape systems? Well, I think this video will highlight that for you. As you can see, it's a very modern video.
Speed to nearly 300 miles an hour. And now let's see him try bailing out. Made it, but only just.
I think health and safety might have something to say about that these days. So, when we talk about ejection seats, we're actually talking about what we call an aircraft-assisted escape system. Now, this is an escape system because he's got a seat, he's got a bloody great spring, he's got a harness, he's got a parachute, and he's got a catapult that will launch him clear of the tail. And if you look at the date, I don't know if you can see that down there, 1922. All I will say is thank God this was never used. But you can see they were thinking about the necessity to have a means of getting the pilot out of the aircraft. So who invented the ejection seat? Well, I've left this slide in, and I actually know this is wrong now, but for a long, long time, and you'll notice there's a question mark after the word seat, for a long, long time we believed that this chap, Ulf Weiss-Vottmann, who was a German Nazi, very, very clever guy, but we believed he invented the ejection seat. And his very first ejection seat was an air-powered system, so purely on pressure. He then developed that seat onto what they call the Dornier field aircraft, and that's when he introduced explosives to the seat. We've subsequently found out that the actual original inventors of the ejection seat were the Swedes. So, Martin's Airworks went to Martin Baker. we were approached by the Ministry of Supply, who everybody knows now as the Ministry of Defence, and we were approached to come up with a way of assisting pilots out of the aircraft. And they approached two companies. They approached ourselves, Martin Baker, and a company called ML Aviation, Mobs Bell Aviation. So this is the model that we actually produced. It was all beaten out of aluminium, fantastic model, and we still have this back at our Denham site, back in 1944, and it's called the swinging arm. It's pretty self-explanatory when you look at the picture. And again, even though it's a Martin Baker item, thank God it was never used. But the Ministry of Supply liked it. And just as a matter of interest, this model was actually thrown away. It was thrown in the skip. And luckily, somebody saw it and rescued it. So, it had been decided that Martin Baker were the people who were going to produce an ejection seat or a means of escape. So we needed somebody to test it. Now, it's a very fine line between bravery and stupidity. This guy here, Benny Lynch, did 31 live ejections, 17 of which were airborne. And I was going to say his ejection career, if you can have such a thing, was brought to an early demise because on his last ejection, he made a perfectly safe ejection, but unfortunately hit a fence and broke his ankle very, very badly. So that put the end to it. Now, how did we get this, I was going to say idiot, but he's not an idiot, but get this silly man to jump out of a perfectly serviceable aeroplane with a relatively unknown quantity? Well, by all accounts, he liked to drop a whiskey. And Sir James Martin used to give him whiskey. Now, we're not actually sure whether it was before or afterwards, or probably a bit of both. But a lot of people owe their lives to this guy because he did a lot of very important testing. Obviously, these days, it's all done by mannequins, it's all instrumented with accelerometers, everything is measured on the mannequin. But when you've got the human interface, he can actually report back to you. He can tell you what it felt like. Christ, that hurt my back. But we can get it all now electronically.
Watch carefully, as in the special rear cockpit, Lynch gets ready to fire himself out for the second time. As the seat leaves the plane, the stabilizing drogue preventing the seat turning over in the air opens and then pulls out the seat parachute. Normally, only the drogue is used. The parachute has been fitted solely to prevent damage to the seat during these tests.
So that's still the seat on the parachute. He's not got a parachute yet.
Now, in his own time, Lynch can free himself from the seat. Watch just below the white canopy, and you will see Lynch's own parachute open as he falls clear.
So a long, long time on the very early Mark I ejection seats, the pre-production seats, from handle pull to going onto the parachute could take anything up to 30 seconds. So it's a long, long time. So again, another picture of Benny Lynch, but while we're talking about testing, the other guy that had a big role to play within the Martin Baker testing was this guy here, Doddy Hay. He carried out the first 0-0 ejection. Now, by 0-0, I mean 0 height, 0 speed. So if you guys and girls were all strapped into your seats there and there was plenty of explosives, you would make a perfectly safe ejection from where you're sat. Obviously, we need to remove a few tiles first. So, we move into something that's starting to resemble one of our ejection seats. And this was the pre-production ejection seat, the prototype. And it was designed to fly in the AW-52, the Armstrong Whitworth 52, better known as the Flying Wing. In 1949, Joe Lancaster had to use this seat in anger. And I met Joe for the first time probably about 13 years ago, and he told me all about how this happened, and he got a flat spin, massive, massive vibration. He couldn't read any of the instrumentation, So he did what he was taught instinctively to do, was to pull the firing handle up at the top. In those days, we only had one firing handle at the top of the seat, and that was it. And again, you've just seen the video of how long it takes for the parachute to be deployed. Well, Joe Lancaster had the same issue. He pulled the handle, he was launched from the aircraft at a great rate of knots. He then had to release himself from the ejection seat. He then had to pull the ripcord and deploy his parachute. But if it hadn't been for this seat, without a shadow of a doubt, he wouldn't be with us. And he is still with us. I'm not sure if you're aware, we had a big event. We celebrated 7,500 lives this year. And Joe Lancaster, at the sprightly age of 96, was our guest speaker. He's a little bit shorter. So, as I said, that was the pre-production Mark I seat. We then moved on to our first production seat. It's become a little bit smaller. It's a little bit more, there's a little bit more thought gone into this one, but it's still very much a manual seat. So when we say manual operation, basically, he pulls the firing handle at the top. It does exactly as I've just explained for Joe, gets him out of the aircraft. He then has to release himself from the seat. He then had to deploy his own parachute. I was out in Peru in 2009 training, and while I was there, I noticed there was a squadron of Canberra aircraft. They all had Mark I seats in it. Thank God they never flew again. At the end of the day, in its time, the Mark I seat was cutting-edge technology. But in this day and age, there's no place for a seat like this because it's so slow. If you're up at altitude, 30,000 feet, no problem, you've got the luxury of time. It's when we come down low that our seats really do come into their own. The Mark II. This was quite a leap forward because this was our first seat that became fully automatic. And because I'm quite sad, I know this is a later version of a Mark II. And the reason I know that is because it's got two firing handles. We now have one down here and one up here. The reason for two firing handles, well, if ever, there are plenty of old seats flying around with two handles. If ever you come across one of these aircraft, the primary means of initiation should always be what we call the face screen firing handle. And it's called the face screen firing handle because it does exactly that. When you pull the handle, it pulls a screen over the face, which protects from wind blast and everything else, but more importantly, it gives you a good posture on ejection. That's one of the issues we have at Martin Baker. Limb flail, head and neck loads are our biggest issues, and lumbar compression. So we're always trying to improve. So if ever a pilot is flying with an older aircraft and they've got two handles, we always instruct to use that handle. The problem pilots were having, they were saying when they ejected, because of the high G that they were experiencing, they were struggling to get the hands up there. So we introduced a firing handle down below so that the hand was straight off the column, straight onto the firing handle. So that's why we had the two handles. Just going back very quickly, no runway capability. Now what we mean by that is that the pilot, if he's hurtling down the runway, there's no point in pulling the handle because this seat was not designed, it could not cope with an ejection on ground level. The Mark III, well, we now had a runway capability, as you can see on there, of 90 knots. It was quite a vicious seat. This was one seat that did a lot to destroy the morale in the Air Force because it was fitted to the V-bombers. Now, you may or may not be aware, the pilot and navigator got ejection seats. The rest of the crew, it was every man for himself. Sir James Martin was absolutely distraught over this. He tried and tried to get the Ministry of Defence to redesign the aircraft so that they could put seats in, and they wouldn't. And there have been tales of pilots and navigators who have died because they refused to leave the crew in the back. Not a problem if you're up high. You've got plenty of time for the aircrew to bail out with a normal parachute. But if you're down low, no chance. The other thing about this seat, I've just mentioned lumbar compression. This seat was vicious. Our seats are full of explosives, but this, we use secondary cartridges. Now, secondary cartridges are there. Funny enough, they follow a primary cartridge. But this had 4 secondary cartridges. It was so vicious, it was an 80 feet per second ejection gun. And that was causing pilots, yes, they were alive and thankful of it, but they were coming back and they were saying, oh, my back hurts. So we actually removed one of the cartridges just to slow it down. So the Mark IV. The Mark IV is now basically what every one of our ejection seats, all the way up to Mark 14, is based on. This was, there's still plenty of Mark IV flying around, but we still have the runway 90 knots. So what I always say to people, if you're hurtling in your aeroplane down the runway at 85 knots and you're just about to go into a brick wall, I would suggest to pull the firing handle, because there's a very good chance it's going to work. But we work on statistics, and we have what we call an envelope. And we know that as long as you're within the weight range for this seat, if you eject at 90 knots or above, ground level, you will be fine. The seat's tested to that. We can almost guarantee it. But if you eject what we call out of envelope, we can't guarantee that it'll work. So the Mark V, based on the Mark IV, as I was just explaining, for the US market. Now, you may notice this is a bit bigger, and I think this coincides with the introduction of McDonald's. It's not in service because the aircraft are not there, but it doesn't. The seat was a very, very good seat, but it didn't have a rocket pack, so we still had a runway 90 knots capability. The Mark VI, I showed you a slide earlier of Benny Lynch and Doddy Hay. Well, the Mark VI seat is what he was testing. The Mark VI seat was our first ejection seat that had a rocket pack. So this gave us the 0-0 capability. And the very early Harrier aircraft had the Mark VI seat fitted. The Mark VII, a converted Mark V, and if we go back a few slides, the converted Mark V was a converted Mark IV, and so on. So as you can see, the Mark IV leads into most of these slides. I'll just draw your attention to this little unit on the side here. It's what we call the PCU, the Pitch Control Unit, often referred to affectionately as the dial-a-weight. So what the pilot would do, he would dial his nude weight into the dial-a-weight, and if you follow this linkage down, it's directly connected to the rocket pack. And the idea being that it altered the pitch of the rocket pack to give a different trajectory for the pilot weight. It was so successful, we've done away with it. The problem we had, pilots weren't putting the right weights in. So it was still being used right the way up until the Mark X seat, and then we did away with it. We're now looking into that type of technology again. But we've moved on a little since then. Oh, we've done it again. If you remember the aeroplane, so we got to 1, 2, 3, 4, 5, 6, 7, 8. The 8VA. Now, TSR-2, I'm sure looking around the room, there are 1 or 2 people who remember the TSR-2. TSR-2, Tactical Strike Reconnaissance, was a phenomenal aeroplane. It was way, way, way ahead of its time. It was cutting-edge technology. This seat was designed for the TSR-2, for no other aircraft. And the aircraft was scrapped. Good old politics and governments got involved, and as I said, the aircraft was scrapped. So because the aircraft was scrapped, so was this seat. So the 8VA came to nothing. This was our first ejection seat to have only one, what we call a seat pan firing handle, a handle down the bottom. We had now done away with the face screen firing handle. As I say, this was a pre-production seat. This was not a production seat. So at the moment, any of our production seats still had 2 firing handles. It had much better. I mentioned limb flail and head and neck loads. This was much better limb restraint and everything. It was much better than the earlier seats because it was a development seat. As I say, a lot of the technology from this was taken on, but this seat was scrapped. Which brings us to the Mark 9. The Mark 9 seat, still plenty of these flying. In the Jaguar, you may notice, I don't know if those at the back can read this, but the 9A and 9D seats were fitted to the Harrier. Now, you'll notice there's a caption up there. The Mark 9A has a high sink rate capability with a 2-inch rocket motor. What the hell does that mean? Well, basically, I'm sure you're all aware of the Harrier could hover. Now, I'm not particularly clever, but I do know that aeroplanes like airflow over the aero surfaces because it causes something called lift, I believe. The Harrier, if it's in the hover, you don't get this airflow over the wings. So if he has a problem with the engine, he falls out of the sky like a brick. And it's that we call a high sink rate. So the rocket packs on the other seat and all of our other seats are not there to accelerate the seat. We're trying to look after the pilot. So from pulling the handle, there are a whole series of explosions going on. But at any one time, we're trying to, if you can imagine a graph, we're trying to make his transition from aeroplane to clouds, something like that. What we don't want is bang, bang, and big things like this because you're going to injure him. This was an exception with the 2-inch rocket motor. The rocket motor actually did accelerate the seat. But there are no more of those flying around, but there are still Mark 9Bs fitted to the Jaguar aircraft. The Mark 10. The Mark 10 is what I affectionately refer to as our bread and butter seat. There are nearly 80 variants to the Mark 10 seat in many, many different aircraft around the world. And essentially, this is the seat that the Red Arrows fly with. The Hawks have all got Mark 10 seats. It's a fantastic seat. It's quite an old design now. It was designed in the 80s, and we are still manufacturing Mark 10s now. 0-0 because we have the rocket pack the same as we had on the Mark 9. So, phenomenal seat. Tornado, which is what this seat that you're looking at here actually is from. The Tornado, still plenty of those flying. We did a huge modification program on the Mark 10 seat for Tornado. And you'll see another Mark 10 in a second. And I affectionately call this the Mark 10 heavyweight seat. And I know that because it's grey. And if you see these seats together, if I had two on the stage here, you'd be able to see the skins of the seat on the grey one is much thicker than the lightweight version. We have a reel up here, a harness power retraction unit to pull him back into the seat. On the grey seats, it's much bigger. Everything about this seat is bigger because it was our entry level. It was only from testing and checking and saying, well, we can do this, we can remove weight from there. We then changed to the Mark 10L. And if ever you see an ejection seat, whether it's 16LA, 10LP, if it's got an L in it, the L stands for lightweight. So the side skin, not that you can see on the picture here, but the side skin is much, much thinner. The harness power retraction unit is much smaller. The time release system is much smaller, so it's a much, much lighter ejection seat. Performance, we're talking from handle pull to parachute, and I always call that A and B. So handle pull is A, parachute being B. We're talking about 2.25 to 2.5 seconds. So it's a phenomenally quick seat. It's a far cry from the 20 to 30 seconds that Benny Lynch was experiencing. So I mentioned earlier about the 8VA, and I said, here we go again. And what I was referring to was we've gone through all of our seats, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8. And the aeroplanes went 1, 2, 3, 5. Well, the reason, if you remember, cast your mind back, the TSR2 seat was scrapped so it meant we had a hole in the market. So we filled the hole with the Mark 8 seat. Now this Mark 8 is essentially exactly the same as the Mark 10 I've just been talking about, the difference being it has no rocket pack because we needed to cut the weight down on it. Because it has no rocket pack, we have a runway limiting factor. Now you may remember on the earlier slides, on the earlier seats, we had a runway limiting factor of runway 90 knots. With the improvements of explosives and our understanding of how explosive works and the different types of explosive, we were able to improve things. So instead, and improvement in parachute deployment techniques, we were able to reduce that to 60 knots. The Mark 11. Essentially, it says on there it's a lightweight Mark 10. That's an understatement. It really is a lightweight seat. It's a tiny, tiny little seat because it fits in a little aeroplane. The PC-7 Mark II and the PC-9 aircraft both have the Mark 11 seat in there. Because it's so small, it has no rocket pack, and again, because it has no rocket pack, we have a runway limiting factor of 60 knots. The Mark 12 seat. If we have time at the end, I'll show you a video of one of these seats, of one of the Mark 12s being used. The Mark 12 was a fantastic seat. It was quite a big step forward for us because it had a mechanically controlled multi-mode selector. And basically what that did was it gave the seat the capability to decide, do we need a drogue parachute or not? Now, a drogue parachute is the same as a drag chute on a dragster, a brake chute on an aeroplane. It's there to slow and stabilize the seat. Now, if the Harrier, which essentially is what this seat is designed for, is hovering, why do we need to slow and stabilize the seat? We don't. What we need to do is get the guy on the parachute. So we want A and B as close together as possible. So this multi-mode selector had the ability, and it did it mechanically, it had the ability to decide we're not going very fast because it has pitos on the side. The information is fed back in. It makes this decision, and it says, we don't want a drogue. So the pilot will go straight onto a parachute. So this seat is now, we're now down sub 2 seconds, probably about 1.9 seconds for the Mark 12 seat. There are still some Mark 12s flying, but not in Harrier aircraft. They're out in Taiwan, I think, in a Chengdu aircraft. Not quite the same seat, but similar. It speaks for itself. Could you imagine us trying to sell a Mark 13 seat? Ain't going to happen. Mark 14, NACES. NACES actually stands for something. And this is a fantastic seat in that it means that we can use one seat to fit multiple platforms. The NACES stands for Navy Aircrew Common Ejection Seat. And the big thing here is the common. Because we can fit it to when the F-14s were flying in the F-14s, the F-18s, and the T-45. That in itself you might think is fairly insignificant until you think about the aircrew. Because it means the aircrew have now got out of their T-45 training aircraft and they jump into their F-18 fighter aircraft. Very little difference in the seats. There are some differences, obviously, because the cockpits are different. But essentially, they're sitting in the same seat. So they don't have to go on a re-evaluation course. They don't have to relearn another seat. But it doesn't just go there. It goes to the mechanics as well. If the mechanics are trained on a Mark 14 in a T-45, and then they are then posted to a fighter squadron with F-18s, essentially, they've got everything they need to maintain the seat. So the NACES is a very, very good seat. It's quite an old seat now. The big thing I haven't mentioned about it yet, we've just mentioned the mechanical multi-mode selector. We now have electronic sequencer technology. So this can do the same thing, but electronically. So we now have cartridges that are electrically initiated. So not only they're fired either mechanically, but as a backup, but they're fired electrically as a primary source. So it has the ability, I mentioned about releasing the drogue parachute to slow and stabilize. Well, this one will always release the drogue parachute. However, as soon as it deploys, it will get rid of it straight away. So essentially, it'll deploy and release. On all of our other seats, we had to have a drogue. We had to, except for the Mark 12, because the drogue is what pulled out the man-carrying parachute. But on the Mark 12 and the Mark 14, we have what we call a PDRM, which is a parachute deployment rocket motor. That essentially is a rocket that will extract the parachute. So we don't need the drogue if we are low and slow. Still plenty of these being made, lots and lots of these manufactured. Mark 15. This was a strange little fellow. The Mark 15 was very, very small. One thing we do at Martin Baker, not only do we make new ejection seats for new aircraft, we do a lot of retrofitting. And a prime example, when we went back to the Mark 10, one of the captions there, it will have said on there, easily retrofitted. And what that means is a prime example, let's say the F5 in Brazil. They had their own ejection seats. They were Northrop ejection seats. And they're slightly dated. And getting all the parts and the explosives for them now is becoming harder and harder. So Brazil took the Northrop seat out and they put a Mark 10 in. Well, we do this with other seats. A lot of countries for F5 and T-38, essentially the same aeroplane, they've upgraded their aircraft, taken Northrop seat out, and put a Mark 16 seat in that we'll see later. But this one, the company Pilatus, approached Martin Baker, and they had this aeroplane, the PC-7, not to be confused with the PC-7 Mark II that I was talking about earlier, that had the Mark 11 seat. The PC-7 was a tiny little cockpit. And Pilatus came to Martin Baker and they said, we'd like an ejection seat in our cockpit. Can you help us? And we said, yeah, of course we can. And we went out there and we thought, geez, there's not a lot of room. It's a very, very tiny cockpit. So we thought, well, we've said we can do this. How can we do it? So we looked at feasibility studies, we checked it, and we did all the measurements. And we said, if he ejects using this seat, he's going to be kneecapped on the way out, which is really bad. So what we did, the sitting platform collapsed. So in this seat, you went out standing up. We've had 3 successful ejections, and I might add we've had no non-successful ejections. The later version of this, we actually did more checking and testing, and we realized there is just enough clearance, so we don't need to have him going out standing up. But it was a successful little seat, and it catered for a niche market. There are no more of these flying now. But the one thing, not very easy for you to see from this picture, but twin gun technology. All of our other seats have had what we call single ejection gun. The beauty of the twin gun means that on a single gun, if you could imagine my device here is part of the single gun, it means that the seat was this far out from the bulkhead and then the seat was on the front of it. On the twin gun, we were able to put all the bits and pieces between what I affectionately refer to as the U-bend. So everything went up in the middle, so it could go much flatter against the rear bulkhead of the aircraft. So we could save a lot of space, and that's one of the beauties of this. Our seats now, that's the way we go, is twin gun technology. Just a couple of test shots. This is one of the hazards we get. When we do testing like that, it looks fairly innocuous, but it doesn't take much of a breeze to drag what is a very heavy mannequin across the ground, because the parachute we had in question there was a GQ 5000, which is a 21-foot flying diameter parachute, and they make fantastic kites, which is not good when you're testing and you're trying to catch the things. So they do have a lot of problems with the wind getting inside, so we try and jump on them very quickly to deflate them. The Mark 16A. Eurofighter, Typhoon, EFA, whatever you want to call it, this is the seat that's fitted to it. Sequencer technology again, electronic sequencer. Within this sequencer, there essentially are what I refer to as like 3 little laptop computers. 3 circuits. And they all talk to each other because it has a voting system. So these little computers all talk to each other, and let's say computer A says, we are flying at 200 feet at 200 knots. Computer B says we are flying at 200 feet at 400 knots. Computer C says we are flying at Mach 4 at 35,000 feet. A and B will have a little bit of a discussion, and they will say, this man's talking nonsense. So they will take that out of the equation. They'll get rid of computer C, and they will say, well, you said 200 and 200, and I said 200 and 400. Let's go in the middle, and that's the mode of ejection, 200 and 300, and that's what it'll do. It makes this decision in 50 milliseconds. It's pretty quick. This seat, going back to when I said A and B, this seat has the capability of putting the pilot on the parachute in 0.67 of a second. We actually have to slow it down because Typhoon has a huge, great canopy. So we slow it down, and in its slow mode, in its slowed down version, it's 1.2 seconds. So it's still very quick. But, as I said very, very early on, if we're at 30,000 feet, this seat is no better than a Mark II seat. Because it doesn't matter. When we eject, we've got emergency oxygen. He might have his newspaper with him. He's reading it on the way down or whatever. But when we get down low, the Mark 16 really, really comes into its own because it is phenomenally quick. It's a big, heavy seat, but it's very quick. 16L, it's a Mark 16. It's just a lightweight version of the one we've just been talking about. Again, this is quite big business for Martin Baker. We do a lot of retrofitting, and I alluded to it a few minutes ago when I mentioned about Brazil and their F5s. They have the Mark 10. A lot of Air Forces have, in their T-38s and F5s, have gone for a Mark 16, and it's something similar to this. Very, very good seat, very, very light compared to the one we've just been looking at. No electronic sequencer on this, it's all done mechanically. So all the firing units are fired either by gas pressure from another cartridge, but none of it is fired electronically. So, the US-16E. This is, at the moment, I would say our most technically advanced production seat. It's a fantastic seat. It's a big seat. It's a quick seat. It's also a very, very comfortable seat. I was at Fairford last year, and I had a pilot came over to the stand, and I happened to we had a US-16E seat on the stand, and he'd flown in, he came in his flying overalls, as pilots tend to do, and I said to him, what have you flown in? I expected him to say something like a bulldog or a chipmunk or something, and he said, I've just flown in Eurofighter. So, have you sat in the JSF seat? And he said, no. And he sat in it, and he could not believe how comfortable it is. It is actually a very comfortable seat. There's a lot of testing, a lot of work gone into this seat. It is a phenomenal seat. Auto-eject in STOVL. What the hell is that all about? Well, STOVL is short takeoff, vertical landing. And I still have to say it's not as good as Harrier, because Harrier can do it both ways. This can only land vertically. However, JSF, Joint Strike Fighter, has 2 lift fans. And the problem there is with the 2 lift fans, should the front lift fan fail, the aircraft will tip. It will tip so quickly that it's doubtful whether the human reaction time will be quick enough to pull the seat firing handle. So we have auto-eject. So essentially, the first time the pilot will know anything about this is when he's sat on the end of a parachute thinking, where the hell's my aeroplane? It is only active in the hover mode, in the Stovall variant of the aircraft. The conventional aircraft don't have it, they don't need it, because it just flies like a normal aeroplane. But in the Stovall mode, as I say, when you transition into hover, then that cartridge becomes live, and the seat and aircraft talk to each other, and they will know a lot sooner than you do that there's a problem. And before you know it, you're on a parachute. Ultra lightweight. This slide's a little bit out of date because it's a development seat. It's one we're working very hard on. Initially, it was at 38 kilograms. I think we're now at 45 kilograms. But fantastic seat. It's very quick. But this seat is designed to be used for as I say, the student who's just left university, got the flying scholarship, and the first aeroplane he or she is going to set foot in is this little puddle jumper. And if he's lucky, he or she, given a parachute to strap on, and if there's a problem, they climb out and bail out. And it's just an over-the-side bailout. This gives them the ability to have an ejection seat in the same aircraft because it's so light. But because the aircraft it's designed to be used in don't fly very high, so we don't need any protection from altitude. It doesn't fly very quickly, so we don't need to deploy a drogue parachute to slow and stabilize the seat. All this seat does, I say all, it saves a life. But he pulls the firing handle. He's launched out of the aircraft very, very quickly. Fully automatic parachute deployment. Part of the weight saving is no rocket pack. So we have a runway 60 knots. But it's a light little seat. Ejection on this, about 1.2 seconds. So it's a quick seat. But this is something we are currently working on at the moment. So, another one that we're working on is the next generation trainer, TX, and TX stands for Trainer X because we don't know what the aircraft is. But essentially, this is our latest project, a lot of development testing to go on this seat. There's a long, long way to go, but essentially, we've taken the best of the technology we have, as with everything we've done so far. We'll take the best bits of this seat and the best bits of that seat, and we'll say, well, let's marry them together, and hopefully what we're going to have is an absolutely phenomenal seat when all the testing is done. We do a lot of our own flight testing. We operate 2 Meteor aircraft at Charlegrove, just up the M40, and these 2 aircraft are maintained by ourselves, and they are in pristine condition. Unfortunately, the poor little things do get a little bit scorched by the rocket pack burning. Now, you can see the rocket pack. Any of the rocket packs only burn for about 1/4 of a second, 0.25 of a second. This one here, 638, again, Meteor. Now, I say the Meteor aircraft, these are the best cut and shut you'll ever come across, because they're a mixture of 2 different aeroplanes, both of them are. They are actually T7.5s. And I can't remember which way round it is, but the front end is, let's say, T7, and the rear end is T7.5s. And what they found was it gives it the best stability and flying characteristics. So we have 2 Meteors that are cut and shut, so they're neither T7 nor T8, they're T7.5s. Interestingly, up until October last year, this one was the oldest military flying jet aircraft in the world. But we've now bought it. It's now on the civil register. It's not part of the military anymore. So it's still flying, but it's not the oldest military flying aircraft because it's ours. Couple of test shots. We have our own test track over in Northern Ireland near Belfast at Langford Lodge, where we do a lot of the high-speed testing. You can see the JSF. This is a particularly good picture because you can see there is the drogue parachute, which slows and stabilizes the seat. When the time is right, the drogue is released and the head box is deployed. The March 16 variants of seats have a totally different method of deploying the parachute. On the old ones, as I mentioned, the drogue pulls out the parachute, or I mentioned PDRM, the parachute deployment rocket motor. The parachute comes out of the top. On the Mark 16s, the parachute comes out from the bottom. You're thinking, how does it do that? Well, it actually fires the parachute container. And as it comes out, the lid opens on the parachute container and the parachute comes out from underneath. And that's how we're able to get the man on the parachute in A and B so quickly, because of the way we deploy it. What can I say? I used to have quite an exciting slide here. I had one of these with a fire extinguisher on it. Helicopter crashworthy seats. On a more serious note, big business. We've looked at helicopter crashes, and we look at statistics, and statistically, more people have been killed or seriously injured in helicopters, and this is going to sound pretty stupid, but by hitting the ground really hard. Now, I don't mean flying into the side of the mountain or crashing into each other. I mean literally hitting the ground really hard. So with these seats, we were able to withstand really high G loads, 25 plus G, heavy impact load. So they are big business. And I always get a lot of stick for this because I always make fun of these seats, but they're very good. We have, however, fitted an ejection seat to a helicopter. But you may have already thought a little bit ahead here. There's a bit of a problem with the helicopter in that we have a mincer. What we did, we fitted explosive bolts that blew the rotors off, and then the seat was sequenced afterwards and released. But we come back to the statistics, we looked at it and we said, actually, we don't need an ejection seat, and I believe the Russians still operate an ejection seat in a helicopter, but we've looked at it and we've got so many air forces around the world looking at these seats. And as you can see, there's a selection of the different helicopters and aircraft that have the crew seats and the crashworthy seats. So very, very big business. And I was out in the Philippines 3 weeks ago, and I was out there doing another job, and I said, oh, by the way, they told me they're just about to buy a load of helicopters, and I said, we can fit seats, and they said, we didn't know that you did seats. And I told them, and they're now very, very interested as well. So a lot of people don't realize that there is such a thing as a crashworthy seat. And there is, and it's a good bit of technology. Something we're very, very proud of. Obviously, on the flyer that you got sent around, I think it said 4,900 and something. We're now, as of yesterday, at 7,510. Yesterday, we had a mid-air collision between two F-18s from the US Marines, and one of the planes landed. They were both single seats. One landed, the second one, the pilot ejected, and he's fine. So we're now at 7,510 lives saved by Martin Baker, and again, it's something that all of us at Martin Baker are very, very proud. A lot of people have always asked me, and I don't know if it's a question that may be coming in a minute, who are our competitors? Well, just preempt that question. We do have competitors. Our biggest competitor is UTC, United Technologies in America, who used to be a company called Stencil, who were bought out by a little company, you may have heard of them, BF Goodrich, and then UTC took them over. They're our biggest competitor. We then have the Russians, Zvezda. They make a fantastic ejection seat. The problem with a Russian seat is typically Russian, it's big and it's heavy, but it's a good seat. The K36 is a very good seat. The Czech Republic have a seat company, Aeronautical. They have the seat. Not a big threat to us, but they do have their own seat. And we have the Chinese. Sorry, William. They have a direct copy of our seat. The thing I will say is it doesn't matter who makes the ejection seat. If it saves a life, it's a good ejection seat. Not as good as ours, obviously. I have, before we just go on to questions, I have got a video of live ejections, so it's up to you. We can either do the live ejections or questions now. Shall we put the live ejections on first and then do questions? It'll give you a chance to think then, wouldn't it? Some of the picture quality, I will apologise because it's very, very old. This is an interesting one. Second flight of this aircraft, so prototype aircraft, flying along. It's got 3 hydraulic systems. Fantastic. However, there is a little snag. All 3 hydraulic systems went through one union. There wasn't a lot of thought gone into that, obviously. Guess which bit broke? So he's dumping fuel. He's flying back purely on engines. He's got no hydraulics at all. Now, just to preempt, it's a twin-seat aircraft. So in a command ejection, now you notice the undercarriage has gone down. They have on the aircraft what they call, I'm sure you're all aware, emergency blowdown, so he can get the undercarriage down. Twin-seat aircraft, command ejection, so one seat can operate the other. He's so close to getting this aeroplane back, but you'll see in a second he'll just nosedive, and you'll get the canopy rear seat and then front seat. The rear seat on a 2-seat aircraft in a command system will always go first. Canopy, rear seat, front seat. And you'll see it in slow-mo, and then you'll also see it from the front as well. So, even though the front crew member initiated this, there goes the seats. You'll notice they went a different direction. We call that lateral divergence. It's not the one with all the smoke pouring out of it. It's the one on the left-hand side. And it's not very easy to see, but because of the age of the video. But the parachute, you can see they go back down into the fireball. They were both absolutely fine. And if this video runs long enough, you'll actually see they're higher than when they ejected, because their parachutes turned into hot air balloons and they went back up again. This one here, I'm sure you've all heard of FOD, foreign object debris and damage. This was a classic FOD incident. A spanner had been left in the cockpit. When the pilot pulled the stick back, he couldn't get the stick forward. Aeroplane falls out of sky. This was a Mark V seat, which probably doesn't mean anything at the moment, but it's a pre-00 seat. So this guy had the presence of mind to stay with this until he went over the edge of the carrier, ejected, so no rocket you'll see. And any second now, you'll see he's just getting his parachute. Had he ejected back down the ship, the chances are he'd have been seriously injured or killed. A lot of people say to me, how does a pilot know when to get out? And I always say, if in doubt, get out and answer the questions later. So this guy, the wheel fell off his plane, and he thought, I need to get out. So he came down on the parachute, and then when he looked back, it must have been a bit of a, oh God, what have I done? Because there with his engine, the aeroplane with the engine whining, not a problem. The red arrows. One comes to join the party. He had his air brake down and the weight on wheels switch selected. So as soon as the weight came up, the undercarriage went up, but unfortunately he couldn't get any lift. And all that smoke and debris is all from the smoke pod. they rebuilt that aeroplane and flew it again. I think there's a bit of sound with this one, so. Saab Gripen, so a Mark 10 seat. If you look at the ailerons and the canards, these things are all over the place. It's a fly-by-wire aircraft. So basically, the computer decided, let's have a bit of fun, and the pilot had no input whatsoever in this. Perfectly safe ejection. Saab has subsequently changed their software. This video was sent in to us anonymously a long time ago. We didn't know what the hell was happening until somebody explained to us after, this guy was aquaplaning. And what we didn't know also, that he knew, at the end of the runway there was a fuel line. And he decided, yeah, I need to get out of here, and it was clearly the right call. Poor little Hawk. They were having a bit of a play in Portugal, the Hawk and the F-16. And the F-16 joins the party. And that's the demise of the Hawk. The pilot's ejected. You get a good view here. There's the personal survival pack, a 22-inch controller drogue, 5-foot main drogue, and the Aeronautical parachute. And you'll notice when he stood there, the only injury he had was he had spatter marks from the miniature detonating cord on the canopy because he had his sleeves rolled up, because it was summer. Until the helicopter came in, and they put him in the back of the helicopter and dislocated his shoulder. I mentioned the Harrier. You'll notice he'll go straight onto the parachute, the multi-mode selector, straight onto a parachute. The drogue has disappeared in the bag, so straight into the parachute. Pilot error. This one here, I don't know if you want to turn the sound up a little, because the music's important on this one. Not getting any sound. That's okay. But in the background, what he's playing is the Bee Gees Staying Alive at an air show. Obviously a major malfunction, and this is a Mark 14 Nacy's seat. Straight onto a parachute, barely gets one swing. Absolutely fine. Heavy landing, this is a bit of an understatement. Some of you may or may not have seen this. It's on YouTube. The Mark 12 seat again. He stayed with this a lot longer than I would have done. But again, Mark 12 seat. There goes the seats in front. No drogue parachute, straight onto the parachute because he's low and slow. And I think now's a good time for any questions.
From across the globe, from the centre of aerospace, and now to you.
Thank you for downloading from the Royal Aeronautical Society. If you enjoyed this content, please consider showing your support for the Society. Share a link to this presentation by email or on your favourite social networks. If you have an interest in aerospace, consider the professional and personal benefits of membership. Visit www.aerosociety.com.